Hi everyone, welcome to a conveyor meetup. Today we have Arvind who will be presented to us. And before I hand it over to him, just want to go over a few housekeeping items. So I will send out the slides and recording to this meetup probably within the next day or two. Also, if you have questions, please put them in the Q&A. We'll likely get to them at the end of the presentation, so that way there's enough time to get through all the material. And also, if you're not aware, the Conveyor community did create an end-to-end demo of how you can use the different tools within the community to migrate a monolithic application to Kubernetes. I'll put the link to that in the chat. And if you have any feedback for us, we'd love to hear what you have to say. And you can just ping us on the community Slack group, which I'll link to that as well. And with that, Arvind, it's all yours.
Thanks, Jonathan. Going here. Can you see my screen?
Not yet.
Not yet. Let me just present here again. There we go.
Yep.
How about
good
now?
To go.
Good to go. All right. Hi, everybody. Thanks for joining. My name is Arvind Amirian. I'm a principal consultant at Red Hat in the financial services vertical. And today we're going to be talking about modernizing virtualized workloads using Openshift virtualization. So what is Openshift virtualization? It's the Red Hat offering for the upstream KubeVirt project, which lets you bring VMs to the Kubernetes world. It allows you to run VM workloads and container workloads side by side. And this is using KVM libvirt, which has been around for quite a while and is quite a mature technology, and is being used by pretty much every single cloud provider out there. So if you've ever spun up a VM on Amazon or Google, you're using KVM. And now we're doing the same thing in Openshift. So installation of it is pretty straightforward. You can just install it through the operator hub, through the wizard, or you can just fully automate it like I do using the CLI. So the guest that it can support currently is RHEL 678 and the various Microsoft Server versions and Windows 10. Now, that's the officially supported version, but honestly, I've thrown a bunch of other OSs on this for playing around, and everything works great. But this is just the official supported versions. For the VM networking side, so VMs in Openshift by default work with Masquerade. What Masquerade is essentially you have Virt launcher pod, which does the management of the network traffic as well as the VM lifecycle management. So essentially you have a pod that spins up, launches a libvirt KVM process inside of it, and the VMs run in that the VM process is running inside the pod. And all the communication happens through the pod IP instead of the VM IP. Now, that said, you can also attach multiple NICs to the VM. And that also means that you can attach a bridge interface on the host. So it can look like any other VM on your network, which will use DHCP to get its IP and whatnot. And this can be configured either through machine config, or an easier way to do this is through automation called nmstate. And nmstate is pretty cool. This ships with Openshift virtualization. It lets you basically define your networking configuration through a non-destructive YAML. So in this case, an example, you can see that we're creating a bridge interface off of the Ethernet connection called ETH1. And so if you misconfigure this, by the way, nmstate will automatically roll things back. So it does check for health after applying its configuration to make sure the configuration is valid before it lets it be. So the main use thing we're trying to talk about today is the shift and modernization use case for the classic .NET applications running on Windows Server and IIS. So why in the world would you want to run a Windows Server VM on Kubernetes? That is a very good question. So usually it's not always feasible to migrate your entire application from classic .NET to .NET Core all at once, especially large applications. You can have dependencies on libraries that are not quite available for .NET Core yet, or your organization could have created a whole bunch of libraries of your own to be shared that are all .NET Classic dependent. So it might take time to migrate those things piece by piece. So by importing your VM into Openshift, you can basically run your classic workload and your modernized workload side by side, and they can communicate through the Kubernetes service with ease. And this will get a big thumbs up from security because you're not leaving the network. You're not leaving the cluster, and you don't have to open up any firewalls rules there. And of course, it lets you migrate away from costly hypervisors. So to get your VM into OpenShift, there's a couple of different ways. So one of the things, the conveyor community has a operator called Forklift, which helps you migrate from VMware and Red Hat Virtualization directly to OpenShift. And this is also encapsulated in the migration toolkit from Red Hat. This is the kind of the Red Hat offering for the Forklift operator, and this can be installed through Operator Hub as well. If you have other hypervisors such as Xen and Hyper-V, you can use an open source tool called Virt v2v, which can convert, for example, Hyper-V VHD to a QCOW file, and then you can just import it into OpenShift. There's a bunch of ways you can import your VM image into OpenShift. You can host it on a web server. You can publish it to your image registry, or you can use virtctl to just upload the image residing on a server directly to a PVC. So this is a typical kind of use case for a .NET app. You have an MS SQL database, you have a web API, and you have a web UI. And usually you have either the web UI and API on a different server, you're running on IIS, and MS SQL on a dedicated server, or it could be in a server farm somewhere. In this case, we're just going to make things simple. This use case is a small app running on a single server. So you would do, as a first step, you would just migrate to OpenShift. This is just a straight lift and shift to run the VM in OpenShift. Then piece by piece, starting with the UI, then the API, and finally the SQL database can be migrated to OpenShift. This one might be kind of like I was kind of surprised initially when I saw this, but MS SQL running in Linux containers works great, and I'm quite happy with how easy it was to get it going. Building the .NET Core app itself is really easy as well. We have an S2I process where you just directly into OpenShift UI, where you can just point to a Git repo, and it will build a container and launch it for you straight out. Or you can just do it the classic way using build containers. So here we're defining SDK 3.1 image as a build container, building our source project, and then spinning up the final runtime container, the ASP.NET 3.1, and copying our build to it and launching the .NET process there. So let's do a little bit of a demo. I'm gonna close this here. Let's bring up my OpenShift cluster here. Maybe. Cool. So as I said, OpenShift Virtualization is available in the Operator Hub. See here. Here we go. So there it is. So you literally just go through the wizard and you can get going within minutes. And once you've done that, you have now a new option under Workloads. You have Virtualization. So I have a bunch of VMs running, but the main one we're looking at is this Windows 2019 VM. So you can see we have a console view where I can just log into it just like I would normally do. Let's see. The web RDP is not quite as performant as I would like, but you can always RDP into it through an RDP app. I can actually just show it to you in a second. So there you go. So you have a little bit giant there, but you can essentially have the Windows server running in OpenShift right now. And to be able to RDP into it, we need to create a service endpoint. So let's go take a look at that. So we have this service called sorry, one second here. Here we go. Sorry, this service, not the other one. Here we go. We have an RDP service here defined, which is on node port 30240, which will let us directly access the VM through RDP. So let's take a look at that service here. Services, RDP. Here we go. So you can see the node port is defined at 30240, and then we can hit the node itself, and we should be able to just straight RDP into it. Let's try it. Actually, I haven't tried it from my Windows desktop yet. I was running this all on Linux. Look. See where this is running on. This is running on. I know which one is running on. Let's see. 192. Seven port 30240. Here we go. There we go. This is our Windows VM now running in Openshift, and we've RDP'd into it. Let's take a look at what's going on here. All right, so you can see on the right-hand side, I'm running an MySQL server with just a bunch of data in there. And on the left, you can see there is this is IIS running our application, the API, the client list API, and the client list UI. And you can access this via route, just like you would do any other pod. So let's take a look at the routes on this. There we go. This is a route that's defined, that's pointing to, you can see here, it's a route that's defined that's pointing to this other service, which is mapping to port 8082. And as you can see, this is the 8082 is the client list UI right here. So you can see it's IIS is serving that on port 8082. And so let's take a look. There we go. This is the application that's running on that Windows server. And this is the data coming from the SQL server that's being served up via the API. Now, as I said, it's not always feasible to migrate everything at once. So let's go to the next step. Let's take let's get the UI into a container. Let's first take a look at the YAML so you can see what's going on. So what I'm doing first is I'm creating a service that's pointing to the API endpoint on the stage 1 project, which is hosting my VM. And that's the target port is 8081. And as you can see, that's the API endpoint running on port 8081. So we want the UI running in a container to be able to access your VM's API endpoint. And you can see here, the endpoint I'm pointing to for the API base URL is that stage 1 API service that's coming from the VM. And as you can see here, we're actually using the internal service to communicate. So we don't have to egress out to communicate with the VM. So let's apply that. There we go. So now we should have a stage 2 project created. There it is. Great, so let's take a look at the pod. So it's just deploying, and it's running now, very fast. So this is running now, and just like before, we have a route created for it. See stage 2 app UI stage 2. So this is the pod running, and bam, same application, API connection works just like you would run in a VM. And these are now running side by side. So that would be the kind of the first stage. Then afterwards, same thing you do with the API pod, or the API service. And now we have an API and a UI service ready to pod defined and ready to go. And you can see, let's VI into the API spec just so you can see where it's connecting to. So one of the things you can see is now we're defining a service that's going to allow the API pod to connect to the SQL backend on the VM in the stage 1 namespace. And you can see in the DB connection string, we are still hitting the stage 1, the VM that's running in the stage 1 project. And we just kind of give it the credentials and whatnot as part of the configuration. So let's go ahead and get those out. Oh, actually, just as a demo, let's disable, now that the UI is gone, let's stop the, let's stop the IIS service, and we can stop both the UI and the API now. We won't need it. Now this is just running the SQL server, the VM. There we go. Now we have a stage 3 defined. Go, here's the pods. Deployment is complete, and we have the UI and the API pod now running. And also one thing to take a look is that now instead of the UI pointing to the VM, now it's pointing to the actual endpoint running on the pod, the internal service for stage 3, which is, you can see it is defined here. So now the UI is pointing to the service endpoint for the API. Let's take a look at the routes, make sure everything is okay. And there we go. Now the API is getting still the data from the SQL server from the VM. And as the final state, we want to get rid of the SQL server altogether. So let's go ahead and do that. Let's go to stage 4, our final stage for the migration. So I've got a tiny bit of automation just to make things easier here. I just want to show you what it's doing. All I'm doing is creating a couple of config maps, which is going to have the data to populate the information from the database. So normally you would export your SQL database using backup tools, and then you would restore it onto the new SQL server running in a container. I just have automated everything here. I just pump everything into a config map, and as a process, I launch a script, which is this populate DB script, which goes and runs the SQL command to populate the database itself. So let's take a look at that. These scripts. So that's all it's doing. It's literally just running an SQL command to the endpoint that's running in that SQL container, and I am feeding it the SQL file, which has all my data that I had running on my VM. So let's run that guy here. So at this point, we're kind of ready to just shut down the VM. We don't need it anymore. just kind of like, just let's bid it goodbye. It's done its service. Let's go ahead and shut it down. There we go. And stop the virtual machine. You can see my session just got killed and it's shutting down. There we go. So it's checking if my database is empty now, and it's going to populate it with information. All right. So the database pod should be already up. There we go. So this is the MS SQL container that's coming up. So let's get the UI and API up as well. There we go. And now we have our entire stack all in containers. And let's take a look and make sure it's working. Here's my route. And there we go. And we have all our data back as well. So doing it in pieces is going to let you still develop new features while you are doing your ongoing migration to .NET Core. I have had enormous .NET applications which I've worked on, which we've had to do piece by piece, especially things that are dependent on libraries that are just very, especially from third-party libraries that are very slow to migrate. So it's always good to be able to just do this piecemeal, but the final outcome, what you're looking for in the end, is the stage 4, which is everything running now on your in containers in Openshift. So I'm going to just open up for questions.
Thank you, Arvin, and thank you, Miguel, for answering some of the questions already. So Arvin, I'll start off with this one. It came in around right before you went to stage 4, and the question is, did you test the connection with COM plus service or COM plus service?
It doesn't. That's the thing. It doesn't matter what service it is. It long as you expose the port they're running on, whatever the VM needs, you can, as you saw with RDP, for example, you can access any service on a Windows server that you normally would. There's no real restrictions.
Okay.
So one of the questions I see here is, does Microsoft support SQL running in Kubernetes? Yeah, hell yeah. You can actually, I think it's probably an operator hub by now. Let me just check. I could be wrong. Let's see. Oh, no, I guess not. Maybe I'm wrong. They don't have an official, they're not in the marketplace yet, but it is officially supported. This is something that, like the image I have, you can see. Take a look at the image. You can see the image I'm getting is an official Microsoft image. In server 2019 latest. This is an official Microsoft image. This is not a hack. So SQL Server has been out for about, I think, for Linux for about two and a half years now, I think. And running in containers is now pretty common. Like I was kind of surprised at how well it runs right now.
Well, to add on to that, Arvin, so another question just came in. It's for MS SQL. How are EULAs and license agreements handled between Red Hat and Microsoft? Is it an honor system? How do we work with Microsoft to link back to their agreements for prod environments?
That's between, so OpenShift is just your platform. Like this is not something we offer as part of the platform. The licensing agreement is between you and Microsoft. So, and Microsoft usually does it based on honor system from what I remember. And yeah, you just buy your what is it called, CALs, and you're off and going.
Okay. And then and this is a different topic. So Miguel answered this, but I think it'd be good to get your comment on this as well. Arvin, can you comment on general availability and recoverability concerns of the VM and Openshift versus VMware functionality? For example, what happens to the workload whenever worker hardware fails?
That's a good question. So depends on your storage backend. So this is running in my lab cluster right now, and I'm running ODF, or OpenShift Data Foundations, formerly OCS. So I've got a replica 2 setting there. So if one of my nodes dies, I won't even feel it. I won't even notice. So it all depends on your storage backend. And you have also on top of that, snapshot capabilities for ODF. If you're using something like Trident, they have something equivalent as well. So it all comes down to what storage backend do you use for your persistent volumes.
Okay.
And by the way, just like VMware, if you have a good good backend like ODF, which allows for read-write many access type, your VMs can pretty much live migrate from one node to the other if you have to take them down or if you're doing drains or upgrades or whatever. So you have very little downtime, if any.
Okay. And I got a question on talking about the stage one project.
Mhm.
So the question is, can you talk through the prerequisites for setting up the stage one project? Is it
Sure.
the QCal uploaded, already have the pre-built .NET application, or what drivers did you need to install, as well as how did you build the stage one application?
So stage one application was done in Hyper-V, and I used V2V, that open source tool I mentioned, which will be in the slides. You can have the link to, which we'll send out, to convert the image to a QCal. And as far as setting up, like obviously you go through and automating the packages like web deploy and even using an MSI. But this was just for a demo, so I literally just went in there and manually uh, set up all my applications on this server. And this was actually I actually set up that stuff, and then once it was done, I literally took that VHD uh, file from Hyper-V and did the conversion to QCal and did a virt. My method was using virtctl to upload the. Here I can show you the actual PV. I use virtctl to upload the persistent volume to Openshift. 1 second. It is a bunch here. One, this. Let me just double check my actual, um, make sure I got the right naming here. Cool. So here we go. So it was app base. So essentially uploaded to, I use virtctl to upload my QCal to this PV called Win 2019 app base. And you can see my virtual machine is using that to clone its disk. So I'm using data volume template. I'm creating a 40 gigabyte disk and with access mode read write many, and I'm using the source, which is this PVC that was created when I did a virtctl upload. This could have been just as easily, the image could have been just as easily hosted on a web server, and you can just point to it when you're creating the machine. And as for drivers, no, nothing was really needed. The the virtualization client, there's that automatically gets mounted actually when you create a VM. Here, I'll show it to you. See this guy here, it's a container disk virt io win. This image here contains all the things that you need for the VM to function in OpenShift environment. And when you go through the wizard, it automatically gets mounted. So example, let's just get Windows 2019 source. So you can say import URL. I can just say whatever, I don't care. Let me customize my VM. Sorry, I'm just going to put in nonsense just to get to storage. There we go. See Windows guest tools? You can see it's automatically added and mounted as a CD-ROM, and those guest tools get automatically installed, and that's how you're getting some of the what's it called, performance data out of it in your virtual machine view. Go to that. There we go. No, it's off right now, but when it's on, this data is because you have the guest tools installed. This data comes out of it. So all the drivers and everything you need are automatically mounted as an ISO for you.
Okay, thank you. And all right.
So this is.
Oh, go ahead, Arvin.
I was going to say this is installed cluster with OVN via SDN. Okay, so mine is installed with SDN because I have specific requirements. I have a unique use case with my client that requires me to have a bridge interface, and I didn't want to configure a second NIC at the time. Hence, OVN was off limits for me for now. But this cluster is using SDN for its software-defined networking, and OVN is fully supported. The only restriction with OVN is that if you're dependent on a bridge interface for your VM, so you want to basically use your data center services to hand out IPs via DHCP instead of using the internal Kubernetes network, you do have to create a bridge interface. And with OVN, you can't use the primary interface to create that bridge. You need to have a second NIC in your nodes to create that bridge interface. And that's the only really restriction I can think of.
Okay, so this is actually, I think you touched on this question already. But the question is, don't you have to have installed Openshift cluster with OVN versus SDN to have Virt capable cluster?
No, SDN, yeah. This is all SDN, but it works just as well with OVN, with just that minor caveat.
Okay. And then,
Sorry, go ahead.
so one that was in the chat is, will this work on Rosa or Arrow or Arrow?
Okay, so not supported. I've heard there's some hacks out there that you can actually get it working in Rosa and AWS because it's quite flexible. Like you saw, like the performance was decent, right? And this was running, by the way, in nested virtualization. So my primary cluster is running on KVM, and those nodes are now, and that KVM or RCOS node is now virtualizing Windows Server on top of that. So it is decent performance even with nested. It is not supported. There might be hacks out there. I'll have to look into it in terms of getting if there is any for experimentation, but definitely not supported in terms of production workloads.
Okay, and I'm not sure if you would know this. I know we have Miguel on here. Does Forklift consider any backups and or DR that were present in virtualization client settings? Let Miguel just answer that. I don't know if you have any thoughts on that, Arvin, or want to give anything.
Not really. There's depends on what you're talking about. Like if most of the times with DR stuff, it's application level stuff, right? So you have your application that's available in two different data centers, and then you're literally pointing your load balancer to one or the other. Or if you have an SQL server, you can have something running in active passive state. Again, you're pointing one to the other. So I'm not sure what exact virtualization specific DR setting Alex would be talking about. Maybe Alex, you can elaborate on that.
And Miguel, I don't know if you want to come on and just touch on that a little bit more. I know you answered Alex, but in the meantime, another question from Michael: can you talk about scaling the VM, making the VM HA? What happens behind the scenes? with pods, for example, we have lifecycle management handled by replication controllers. How does Virt compare?
So I think there's some experimental stuff. I don't know if there's anything readily available for that yet. Honestly, I haven't checked with the latest version that just came out. Um, so for VMs, you can deploy into like for example in this use case, there's SQL server running, so you can't just scale up to two and expect your application to work. You're gonna have literally two different databases running. So you do need to consider what workloads running on the VM. So if it's just application code, you could set up a couple of VMs where you can just load balance against via using the services selector here. You can get it to select your multiple VMs. But as far as using deployments, I honestly don't know at the moment. I think we're working towards that if to get deployments to handle scaling, but I haven't tested out at the moment.
Okay. And Michael submitted this is a good question. So what libraries or dependencies are commonly encountered that have issues with moving to .NET Core? Is there a capability mapping that would create a decision point for developers or ops as far as to move the application to a newer version of the .NET framework, or keep it as a Windows virtual machine? And he goes on to say, like, what reference materials for developers do we have to create a decision map on whether to adopt OCP Virt versus .NET Core containers or the WMCO native Windows containers?
So that's honestly an internal audit in terms of development. It's something like, I'll give an example. Like even Microsoft's internal libraries, like Entity Framework, it's not a one-to-one. They behave very differently. And if you have an application that uses Entity Framework for its interaction with your database, going from classic to core is not. It can be simple depending if what features you've used in Entity Core, but it can be also very complex depending on how you've used Entity. So it's honestly you have to do an audit of the libraries used, and you have to go to each of those libraries and make sure that there's a .NET Core equivalent, and if so, look at the developer release notes to see if there's any behavioral differences. Because as I said, like for example, Entity Framework they could have the exact same method and they'll behave differently. So it's not a guarantee that if you have a one-to-one, you'll have identical behavior. You still need to research and test and do your audits.
Okay. This one's more on ACS. So any thoughts on how ACS would work with virtualized workloads? For example, the network behavior baseline, feature flagging anomalies.
I haven't honestly played with ACS yet, but it's all based on network traffic rules, and you're literally the only thing you want as far as network traffic coming out of your VM is the stuff you expect. You have HTTP traffic coming out of, example, coming in at port 8081 through the service. You have possible SQL. You have SQL traffic, TCP traffic coming through forgot what the SQL port is, but it's the same as any other pod, especially if you're going through Masquerade. When you're doing Masquerade, you're basically bound by the exact same rules other pods have to adhere to. There is nothing really inherently special in terms of working ACS for network traffic against pods versus VMs. Now, maybe an exception to that would be if you were to use a bridge interface, which you're kind of bypassing the SDN to go directly to the host. In that case, I don't know if ACS can control that, but you have the same problem if pods do that, if they use a bridge interface versus using the CNI.
Okay, and then the next question, Arvin, is is there any insights or comparisons on how forklift VMs perform in OCP? Is it on par or better than the previous platform? I think it's a pretty wide question, but curious to get your thoughts on that.
Sorry, can you repeat the question again? I didn't get that.
So essentially, is there any insights or comparisons on how virtual machines in Openshift,
Hmm.
how do they perform? Is it on par or better than their previous platform where they lived on?
That's basically it's less to do with OpenShift versus, it's more to do with KVM versus. So if you have example VMware, which let's say I also don't know the performance figure of. If right now KVM performs better than VMware, it'll be the same in OpenShift and vice versa if VMware performs better than KVM. It's not so much OpenShift. The only delta in terms of performance, it would be coming from the traffic passing through the SDN versus having straight host access. But other than that, in terms of the actual VM performance, it should be no more different than running directly in KVM because all that pod is doing is running a KVM process inside of it, and it's literally like running on a host. It's just namespaced.
Okay, yeah, that makes sense. All right, well, Arvin, those are all the questions. Thank you everyone for joining. Arvin, thank you so much for presenting today. And everyone, I did put the link to survey in the chat. If you can please do that before you leave, that would help Arvin and me make sure that we continue to present good stuff to you. All right, everyone. Well, hope you enjoy the rest of your day. Bye.
Thanks for joining, guys. Take care.